real definition of an acid and a base. And with our real definition of an acid and a base, we figured out that if you have an acid, you have a hydrogen ion in the compound. And if you have a base, you have hydroxide. The more hydrogens you have, the stronger it is. The more hydroxides you have, the stronger the base is. Well, we had a situation when we're looking at the list, and as we looked at that list of your acids and your bases, we got down to the bottom one down there, and we realized that ammonia is a base. But ammonia here, the way that it's written, it doesn't have hydroxide. So there had to be something wrong with this definition for Arrhenius. So that led the way for new people to come in and look at these definitions. And Bronsted and Lowry, two people that worked together, actually looked at this, and they figured out that we can have a more encompassing definition of an acid or a base, and they strove to get it. So we're going to have to define a few things before we get to that definition. The first one we've looked at in the last few units, and that's called dissociation. Dissociation is what happens when you put an ionic compound into water. That ionic compound in water breaks apart into its ions. So when you are making a solution here, like we have sodium chloride, that sodium chloride goes into water. That water, the solvent, breaks it apart into its ions, sodium ions and chlorine ions. Now when a sodium ion and chlorine ion hit each other, they go back together, then they break apart again. They go back together, they break apart. And it happens over and over and over. Same thing happens here with your potassium phosphate. Potassium phosphate breaks apart. The two ions that we have present are potassium and we have phosphate. Those two break apart into their ions, they go back together, break apart, go back together over and over and over. So they used this dissociation to look at acids and bases, and they wanted to see what's happening in the solution itself. And as we looked at what's happening inside of the solution itself, the Bronsted and Lowry team came together and they actually figured out that you have this dissociation happening, and you have some components traveling around in the water. So looking at that, they said that when you have these little ions floating around in the water, the hydrogen ion is going to travel from one component and it's going to move to the other component. So it's going to leave the acid and it's actually going to go to the base. So we have things that accept a hydrogen and things that give away hydrogen. So looking at the definition of your acid and your base, one component is going to give away the hydrogen, the other one is going to take it in. The acid is the one that gives away the hydrogen ions. They donate them away off of the compound itself. So when it loses the hydrogen, acids are losers, that is how we can figure out which is the acid. So the acid will always lose hydrogen. Bases are the ones that accept the hydrogen in. So the acid is going to lose the hydrogen and it's going to travel over and it's going to go over to the base. Acids are losers, bases are the ones that accept them in. So what this does for ammonia in the last situation that we were talking about, Arrhenius said that ammonia is not a base because it doesn't have hydroxide. Well, now that we have this hydrogen ion traveling around in the solution, that hydrogen can leave the acid and your ammonia can accept it in. When ammonia accepts it in, it makes a polyatomic ion, ammonium, NH4 plus 1, that's where that comes from. And now you have that in the solution. So that clears the air on your exceptions to the rule with Arrhenius, that now we just have the hydrogen leaving the acid, going to the base. So what you're going to have to do with these is you're going to have to identify which is your acid and your base. And then on the product side, you're going to have to identify the conjugates. The conjugates are what are produced, because basically when you have these in solution, the hydrogen goes from one and it travels to the other one. Well, in the solution, just like with dissociation, they break apart, they go back together, they break apart, they go back together. It can go the opposite direction too. So you're going to have an acid and a conjugate, a base and a conjugate. The first conjugate that we're going to look at is called the conjugate acid. With your conjugate acid, these are the products, and it's what's produced when that base accepts the hydrogen. So in the examples that we're going to look at, you're going to see like the before picture and you're going to have the after picture. The acid and the base are on your reactant side. Your product side are always going to be your conjugates. Conjugates are products. So bases make conjugate acids. Acids make conjugate bases. So it's the product of what happens when you have that acid and it donates away the hydrogen. It does get easier, I promise. So looking at this, you're going to have to identify which is the acid, the base, the conjugate acid, the conjugate base. Looking at this scenario right here, this is not really a chemical reaction. This is what's happening in the solution. They actually should have an arrow that points two directions, forward and backward, but we haven't gotten to equilibrium reactions yet. We'll get to that in the next unit. So this just has one single arrow, just does not confuse you. But when we look at this compound right here looks very similar to this. So this is like my before picture, this is my after picture. When we look at this, like number 1 spot versus the number 4 spot down here, the only difference is one hydrogen. This has a hydrogen, it has lost the hydrogen. Acids are losers. So that means that this right here is my acid. Acids make conjugate bases, so this one is my conjugate base. Looking at this scenario with like the number 2 spot and the number 3 spot, this one has 2 hydrogens, here it has 3. So I've gained a hydrogen. So when you gain a hydrogen, this is my base. Bases make conjugate acids. So when we have to identify this one, this would be acid, conjugate base, base, conjugate acid. So we've got some examples here to go through. I'm going to switch over to my document camera instead of doing these on the screen just so I can write on the paper. And on these we want to identify the acid, the base, the conjugate acid, the conjugate base. So you need to figure out which ones look similar. So a lot of times I have people kind of link them together like this where those two look similar and these two look similar. You don't have to make the brackets like that, but it kind of makes your life easier. So when you look at these two, this one has 2 hydrogens, this one has 3. So this gained a hydrogen. So that means that this is my base. Bases make conjugate acids. Now when we look at these two, here I have 4 hydrogens, this one only has 3. This lost a hydrogen in my before picture versus my after. So this one is going to be my acid. Acids make conjugate bases. Conjugates are always products. Acids and bases are always on the reactant side. Again, these aren't reactions, but it's just the easiest way to explain that. Now looking at these two. This one looks very similar to this one. This one looks very similar to this one. So when we look at these, we want to identify which one lost the acid, which one lost the hydrogen, which one gained the hydrogen. So this has a hydrogen at the end and the beginning. This one doesn't have one at the end. So this lost a hydrogen. Means that this is my acid. Acids are losers. Acids make conjugate bases. This one gains a hydrogen. This one doesn't have a hydrogen. Now it does. Bases gain a hydrogen. Bases make conjugate acids. The next one, you have NH4 plus 1 and CO3 minus 2. This one and this one look very similar to one another. These two look very similar to one another. So when we look at the scenario here, this has 4 hydrogens, that one has 3. That lost a hydrogen. So this is my acid. Acids make conjugate base. Then I have CO3 minus 2. This one gains a hydrogen, so this is my base. This is my conjugate acid because bases make conjugate acids. And then the last one down here, H2PO4 looks very similar to HPO4 minus 2. And then OH looks very similar to H2O. H2PO4, this is HPO4. This one lost a hydrogen in my before picture versus my after. So acids are losers. That's my acid. Acids make conjugate bases. OH gains a hydrogen. So with OH gaining a hydrogen, this is my base. Bases make conjugate acids. So with these, all that we're going to do right now is we're going to look at your before versus your after and figure out your acid, your base, your conjugate base, just like we did here. We won't get into any more detail than that until we get through dissociation, where you might be given the NH4 plus 1 and it's going to say, hey, this is an acid, what is it going to make? And you're going to have to be able to write this, but that's in the next little section of notes. If you guys have any questions, make sure you ask. Otherwise, have a good day.